And in this session, we are going to see about the capacitors in series, right? So, as we know about in lower classes, when it is a series connection, current is constant. When it is parallel connection, voltage is constant. And similarly, here also we have a series connection, but here the Q is constant. Q is constant here. Okay, how it is constant? We will see here. Here I have two different capacitors. I named as C1 and this capacitor as C2 I named here. And these two capacitors are connected to battery. By this plate is connecting to the positive terminal of the battery, and this plate is connecting with the negative terminal of the battery. And obviously the other side will have the opposite charges. So here plus, so therefore this plate will have negative charges, and similarly for this capacitor, this one will have positive charges. Now if you are connecting these two by resistor, by in series, okay, the C1 and C2 capacitors connected in series. So what will happen in the sense, so if you are connecting these two, right, so we will have the C1 and C2, it will have some charges, right. So therefore we have some net charges flowing inside the circuit, right. If the flow of charge only, we are saying the current. Okay. Now what I am going to do same sense, and if there is a charge, if the total charge Q is exist in that circuit, then the current flow will be happen. If Q becomes 0, then there is no flow of current. That's why we are saying that Q is constant when the capacitors are connected in series. Now, as we know the basic concept, the capacitance of capacitors C is equal to Q by V. So the first capacitor, we will represent the capacitance of the capacitor C1 is equal to Q by V1, and for the second capacitor C2 is equal to Q by V2. And here the charge is constant, therefore the voltage only variable component. So total voltage V is equal to V1 plus V2, and V1 we can just rearrange this equation. V1 is equal to Q by C1, and here just rearrange V2 is equal to Q by C2. As the total voltage we have mentioned V is equal to V1 plus V2. What is V1? Q by C1. And what is V2? Q by C2. Therefore the total voltage V is equal to Q into bracket 1 by C1 plus 1 by C2. For the case of if you are connecting only two capacitors, suppose if you are connecting n capacitors, so how we can write the total voltage V is equal to V1 plus V2 plus up to Vn. Therefore we can write V is equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3 up to 1 by Cn. So this area we are called as effective capacitance of a capacitor.